Let's start work on a course model that we receive from outside. Therefore, we open a new model, and with the Insert from File command, we are going to import a standard Exchange file such as step. So, from the list of formats that can be read by ThinkDesign, we select step. By the Options button, we can manage a series of settings, both in loading and in saving, this in order to read and write at the best our import and export files. The different options can be saved to a library of settings to be used later on when necessary. In this case, upon loading, we use the default values, so in Load and Advanced, we select the default button. So, let's import the file to the ThinkDesign environment. In this way, we keep all the settings of our template model, such as colors, layers, and so on. Let's see the result. So, with the different rendering visualizations, shaded view with borders, wireframe, and managing the zoom views, fit view, we can view what we imported. The solid we imported is a static solid type because in the import file the geometry and math of the part is translated, but not the logic, that is the sequence of operations by which the part has been built. However, on these static solids, by ThinkDesign we can add any possible feature. Let's insert a hole, a through one. Let's activate also the axis option. As for the diameter, we enter the value as desired, in this case 18, and we place it in the central point of the face. Now we insert another hole, but this time we retrieve its values from the tables used for screw designation. In this case, an M4 with cord thread. We place it in the center of the edge of the ground face, and we confirm. Currently, we are not viewing the work plane, so in System Options, Reference Systems, we can tick the Show option of the work plane to view it. In this case, we can also manage the absolute reference system, word, that is the origin of our model, and how to place it. For instance, in the bottom right-hand corner as proxy, or in other modes. In the Appearance category, we define to view no other reference entities, but the triad of axes. Now we need 3 more holes at the one just created, and we do it not using the hole command, but the pattern one. Therefore we replay the hole by touching his face, then stating continue, because we don't have any more features to replay but the hole. We choose the type of pattern we want to create, in this case a pattern of type linear, so we need to specify 2 directions. As first direction, we keep the line mode, and we select the edge to define the direction. As movement entity, we don't bother to enter any value, but dragging the manipulator, we move until we snap the center of the opposite face. For the other direction, we specify the Y vector, same mode to specify the movement entity. So, in the history tree, we can see we started from a static solid, then step by step we added some features. In sequence, we find the features carried out. Let's save the job done so far. At this step, by the Save As, we'll save a file type with E3 extension, which is the ThinkDesign native format for models. In this phase, we are going to use datum planes. That's why we activate in the model structure the option showing datum planes. Datum planes are parametric entities In this case, we are going to insert one with mode perpendicular to axis and through point. And as for the axis, we indicate it as x vector. We specify that it passes by that point. Among the other conditions, we want to manage an angle with respect to a parallel axis. Therefore, parallel to y-axis, angle by 15 degrees. Let's now insert another datum plane using an existing datum plane as reference. Therefore, we choose as reference plane and we click on the one previously created. Then we add another condition, parallel, because we want to create another datum plane parallel to the previous one at a distance 18 millimeters. We can possibly change the size of the datum plane to distinguish it from the existing one. Let's see how the entity's datum planes are displayed in the history tree in line with the option that we had previously defined for the model structure. In fact, if we clear this option, datum planes are not displayed in the history tree, while by selecting the option, they are displayed. Now, acting from the history tree on the datum plane symbol by the context menu, we ask to show the driving dimensions for both datum planes. Let's change the value of 15 degrees to 10 for the first datum plane, and we note that, as a consequence, also the position of the second datum plane is changed because there is a relation between them. We can even select them from the history tree or in a graphic way. In this case, we select them from the history tree to change their color to distinguish it from the rest of the model. On the second datum plane, we are going to place the triad of axes whose symbol is a lock. It means that a triad of axes will keep related to the datum plane. On this triad of axes, let's now activate the 2D profile environment and let's create a rectangle with 3 sizes because we'll constrain them later on. Let's draw a line passing for the midpoints of the 2 horizontal lines. This because we'll use it as center line. We zoom in on the area we are working on. Wireframe visualization. Then we make the line just drawn as a reference. Reference lines are not involved in the solid feature, so they will not generate any face, but they are just used as references. Let's set a dimension of 12. Then, by a geometric constraint, we specify that these 2 lines must have the same length. As a consequence, also the others turn out to be constrained. In fact, checking the profile, there are 2 degrees of freedom, so from the geometric point of view, the square as an entity is constrained, but the position of the square in the x or y vector is not managed so far. We actually can drag it, since it's free to move on the xy plane. By another geometric constraint, we are going to set a collinearity constraint between the reference line and the whole center line. Some entities become dark blue, and this means they are fully constrained. By a driving dimension, we are going to constrain also the position of this rectangle along the y vector, therefore with a dimension from the midpoint of the reference line to another point of the ground face. Of course, it is detected a dimension aligned with the current situation. We set for this dimension the value 12, and we rebuild. So, in this case, we have fully constrained the profile. Let's go back to the model environment, and by Hide Entities, we hide the two datum planes as we don't need them now. Then we select the whole solid object, and by the command View, we ask to hide the driving dimensions. The unhide sequence is often used in the model environment. Adding further entities when creating features make visualization a bit difficult, so we often show and cover the different entities.